So, good morning, everyone. Let me introduce myself. My name is Claudio Fecarotta, working for MSA. MSA is a safety company, so today we are going to talk about a very specific topic. We have talked about how to produce hydrogen, how to store, how to transport these very sensible gases. Why not to introduce the technology able to detect any leakage and flame? What are the challenges related to hydrogen? I think that most of you are more than expert than me discussing about what are the challenges coming for hydrogen. Hydrogen is very small molecular and then is very propensity to escape from any small hole or any possible leakage. Very low injection energy, so it's very simple to explode or even to create the explosion. Fast detonation, a wide flammability range. We are talking about from 4% up to 77% volume in the flammable range. Fire consequence. We know that 100% of hydrogen is completely invisible, and that is very tricky for any personnel at work on site working that is not able to see and recognize that there is a flammable. And human-related, when we have flame or a potential leakage, explosion, that will be a problem on the asset of your plant, or even a possible injury in case of a detonation and explosion. So, talking about the challenges. Talking about how is the hydrogen able to leak. I wanted to even invite you to pay attention about this model. This is a study that we have done internally just to explain you that many people think that being a very light molecular, hydrogen is going up. So is deleting to the sky is very safe. I don't concern about the possible risk. Have you talked, if you have a high pressure and your leakage is going on the ground direction, that is the shape that you can have. And I can tell you that after 300 seconds, the shape of the cloud that has been formed by the leakage is maintained by the pressure, and that is the most dangerous thing, because even the process transmitter are not able to recognize that there is a pressure drop or something that even is failing. Another important thing is unpredictable. So that is a word I wanted that you remember, because leakage is a sequence of fault, might be human, mechanical, maintenance, missing maintenance, which is generating a possible leakage probability or leakage likelihood. Wind. If you think about an outdoor plant, as I say, we believe that the hydrogen is going always on the sky, but what happens if in a specific circumstance, this might even influence in a different way and even create a possible risk. That is a scenario without the implementation of the gas and flame detection system. What is the scope of the gas and flame detection system? Our scope is that we wanted to mitigate the risk, so we are not preventing the leakage. The leakage is already there. So that is the last resort in order to avoid that this becomes too dangerous. So we want to push down immediately the possible catastrophic consequence. How we do that? So we have four types of technology able to do that. Let me explain a bit this table, which is quite common in some regulation. We are talking about a release event. If you see from the left of the table is when the gas is releasing. Okay, so that means that the gas is over outside the process, is going somewhere that you cannot predict where, the final destination. So in this case, only a leak detection is able to detect in a very short time. So, and if it is not in place, that detector, it might be a situation where the formation of the cloud is going somewhere under the ceiling, under the rain guard, maybe in some skid. Think about. And if we don't detect it with a conventional gas detector, then become a potential explosion. I mean, I would suggest that never happen this situation, because it will be catastrophic, especially with hydrogen. We know detonation is very, very energy, let me say. So how does it work? The leak detector is based on microphone, like hearing human sense. If we are talking about the human sense, is hearing, so is listening the noise from the leakage. You know that the molecular is vibrating when is pushed by a small hole, and then it's generating the classical noise. Okay, we don't care about the human sense, we are talking about ultrasound. And then there is also a sophisticated artificial neural network able to manage then a possible false alarm from the compressor, from the pump, the truck, whatever that is making a noise in the background in the plant. So we say that we detect at the speed of sound. We can detect in 2 seconds, very, very quick. If the leak detector, so the ultrasonic, is not in place, we are talking about two conventional technology. The first one is catalytic, the second one is electrochemical. What are the differences? Okay, they work pretty similar. They change their molecular, or they react when there is hydrogen, and is generating a signal, what we use for then generating the alarm or the 420 milliamp. That is in fundamental where if you predict during the engineering design, during the design phase, where the possible accumulation of hydrogen is, then you can install the fixed gas detector in order to prevent that the accumulation become dangerous. Electrochemical is able to detect up 1000 ppm, very sensible. And the catalytic one, we are talking about 100% LEL, so means 4% volume of hydrogen in atmosphere. Flame, how does it work? It's based on two sensors, UV and IR sensor. We believe that the combination of the two sensors are able to be very quick in detection of the flame, able to see the flame, the transparent flame of hydrogen, and also avoid false alarm from light welding, arc welding, something like that, that can happen in the plant. So, the complete, what we call protection layer, the complete package of technology and detector are just in these three elements. Leak detector based on UGLD, ultrasonic gas leak detection. Then there is the conventional gas detector with electrochemical and catalytic. And the last but not least is the flame detector, which is based on the ultraviolet and infrared. Those is our package to mitigate the risk of potential leakage and the consequence of an explosion. That is the result. How does it work when the detectors are in place? And if you see the same evolving of the leakage, you see on the right, the ultrasonic is installed on a pole, which is able hearing just the sound emitted by the leakage. And that is very important because it's able to detect, look at the range up to 28 meter radius per 360 degrees. So can cover this area without any problem. All right? Then the conventional gas detector is being installed strategically close to the flange. Let's assume that is a flange. And what's happened, once the concentration is enough to be seen by the detector, in this case it's smelling the gases, okay, goes in alarm, and then you can have your free contact for 20 milliamp, and then you can initiate your safety system. The last you see is not going in any alarm at all, because it's just waiting, and hopefully will not happen, a flame. And our detector is able to see the invisible hydrogen flame, because the infrared is tuned for a specific microwave. So what we are answering today then is with a complete package of technology, we are able to even cover the complete manipulation from the weather. I like this word because it's an unpredictable situation. We use the right technology based on the right application. So we need to discuss, okay, is the catalytic the better, is the electrochemical one? Each plant are different. Each plant is specific. And all the time what we do is to work like a consultancy, like to support the customer or even the engineering company to even understand what is the right technology to have the best practice to detect the hydrogen and flame detection. That is my last slide. I think that the organizer will be happy that I used the all complete time. Do you have any question? Which my answer? Okay, good. Yes, I cannot hear you. The standard, you mean? I mean, if our data is a good question. First of all, thank you very much. So Mr. was asking about the regulation. MSA is covering with our product every regulation in most of the country in the world, like ATEX for Europe, UL for US, Metro Brazil. We can talk about Australia, ESEX. We are talking about ATEX directive because that is a directive that we follow to standardize our products. We are talking about a regulation in terms of installing in the right classified zone, but also for the performance, because for flammability, ATEX is requested to the manufacturer of the gas detector, the performance on the software as well. That is something that a lot of people doesn't know. In terms of regulation of hydrogen, unfortunately, there is no very clear regulation. There are some couple of standard, I don't want to recall the number because I don't want to make any mistake, but in some standard are requested, for instance, for the hydrogen fueling station and for the electrolyzer application, that's to mitigate the risk of the leakage, a gas detector has to be installed as a mitigation risk. For the electrolyzer, I can tell you that the ventilation system has to be triggered by the gas detector when reach 1% volume, which means for us the 25% LEL. So there is starting to, but I can tell you that we are working with hydrogen since now more than 60 years, and we know how to manage in case. Thank you very much. Thank you. Thank you for your attention.